Hello everyone, my name is Dení. For some reasons, I hear my, yeah, no, I don't hear. So I'm here to talk about Meta-serializers, and I had very little time to prepare my slides, and it's actually a good thing that I finally managed on time. And it also shows that C++ reached the point when you can implement something non-really trivial in short time, comparing to old times, if you know what I mean. And I hope you all followed the link and open slides, because there are more links to the code templates, code samples, and I also wrote a blog post about this, so you can always get back to this and read it and compile it and digest it. So let's see what's on our agenda. First of all, of course, I want to give you a definition. What is a serialization? Motivation to solve problems. I will show you a very small and basic solution. We also see a little of assembly, just to make sure that there is nothing odd was added by the compiler and templates and so on. Then we will simplify and systemize this solution. I'll give you close to real world examples. And there is a thought and a hope that we will get reflections and meta classes in C++, and this all can be dramatically simplified. And if anyone knows how we already can use reflections, probably a special branch of GCC, I welcome your thoughts. So this is weird, but okay. So definition, what is serialization? According to Wikipedia, it's a process of translating data structures into a format that can be stored or transmitted and then reconstructed later. So here in my presentation, I only talk about the process, not about format specifically. Formats will be given as examples. So this is the question to the audience. Why would we want to change anything in the world of serializers? Anyone knows the answer or thoughts, or can anybody guess why would we want to change it? Do we see any problems, or are we okay? Okay.
More part of the process which the code gets in, part of the steps. The serializer follows the debugger steps one by one, execute what
Probably.
you cannot make a jump call or control in terms of.
I'm not sure this is related to serializers. Is it? Anyway, so the question, do they consist of boilerplate?
Yes.
What do you think of boilerplate? How do you feel about boilerplate? Are these questions repetitive? Do I look like you're a psychotherapist now? So motivations, so basically reasons to do changes. This stuff is very wordy, hairy, repetitive, and error-prone. Everything has to be kept in sync with your data structures. For instance, if you add a new data member, you have to update all your serializers, and those serializers that depends on your concrete data types. You you have to update them. Also, most of serializers that we write, they are not generic, and yeah, just as I said, every data type has to be done individually and updated, and it's also very tedious and tiresome and may cause depression and probably suicide. Can we make it better? One of my goal in my career and in my job, in my life, is to fight the corporate lifestyle and not to be very silent. And you guys seems to be very silent. And I'm afraid you are working on very sad stuff, and we are hiring, by the way. So how we make it better? First of all, we need to abstract serializers from concrete type. We want to move out any serializers logic from having them from having them implemented as functions that depends on concrete types. We also want to introduce a layer which would provide serializers with data members declaratively. So it's not going to be a function which inside takes. Hey. Hear me well? Better? 1, 2, 3. Okay. I'll just like this. There. So, where we were. Yeah, so it's not going to be just a large functions in which inside. Sorry for my English. In which we just iterate over all fields and write something like send object dot this field and so on. It's going to be abstracted from such things, and we're going to have interface, compile time interface to provide serializers with these fields. And we also want to make a good use of C++ type system. And yeah, we use metaprogramming to iterate over data members. All snippets will be in C++ 20, and they must be, they are able to be downgraded to C++ 03 with some changes if you are feeling good about this. And also, metaprogramming in C++ is very fun. So we can kill the bad points of them being tiresome and tedious. So first of all, let's talk about how we expose our member fields. So first of all, we have a very simple structure, employee. That guy has salary and name. And first of all, we can expose these fields through member function members, which returns a tuple of references to name and salary. It will be intrusive way. It's intrusive because we have to change the class definition but not always. You can just simply change class definition, and you have to work around it and move out this function and use non-intrusive way. So basically, it's the same, but you take employee object and you do the same. Nothing special here. Furthermore, I don't use non-intrusive way, but if you want to integrate this approach to your code base, you always can implement also non-intrusive way. It's very simple to determine if a structure either implements members, member function, or you can call members with this type, and then call the proper function. So now we talk about implementation of abstracted serializer. So this is serializer is very simple. It just prints all values separated by commas. So for our employee, it will print its name and salary. So I hope everyone is familiar with this syntax. It's what's it called? Multiple argument something. I don't remember. Periodic template lambda. And this is a fold expression. So let's see at the solution and run it. So we declare employee Steve Jobs, who had $1 salary. And if we print it, the output will be Steve Jobs, comma 1. It's very simple. We can go to color room and have fun with this. So there is nothing like, in my opinion, there is nothing complicated here. So it's our employee data structure, function members, which returns a tuple of references to name and salary. I hope you actually guys see this. That's not really. I think this is better. So we return the tuple, and this is implementation of our serializer. And this is how we use it, and that's basically it. It's very simple, and yeah, we can also do this beautiful stuff if Godbolt is not offline. Compilation failed. So this is just to show you that there is nothing really extra weird about it. And here you can see LSTR3 is being printed. It's labeled to the, we don't see this. Let's go. No. I better show GCC. GCC is better than selling. No, it's not. I think I just killed something. Oh, it is showing cool stuff. Anyway, Godbolt is quite unstable today. You can do this on your own, and I encourage you to do this on your own. But I assure you that there is nothing weird about it. It simply calls std count cout the value of this name and std cout comma and std cout just the salary name. So we still have boilerplate. And if we want to have a real approach for this, we have to declare members function for a case when your function is when your data is constant or not constant. And also, if we want to see the names of fields, we also generate this function names. Here we use some weird boost preprocessor magic. Basically, it expands to std array and it will be name, string literal, comma, salary, string literal, and that's it. Let's go. Let's see how can we use this macro. Expose members. So this will generate all functions that we need. And here it's going to be used. And so here we use a macro, but as I said, I have a hope that we get finally reflections and meta classes. So this macro can be evicted. And also, as you can see, this macro is kind of very isolated from the rest logic. So once we get a proper implementation with reflections, we can easily remove this line, which would mean that all members has been exposed, for instance. So let's see how it works. Here we see a more complicated example. This is a printer which also prints the field name. So in this example, name equals salary equals. And to implement this logic, we extended our operator left. So this is still the same variadic lambda function. But in this time, we take names. This is our std array that was returned from here. It simply contains the field names. Nothing special here. And we use fold expression. Here we first of all print the first field, and then if we have something else, we print comma, and then we use this magic stuff of pre-increment and do the same for the rest fields. Again, nothing magical. And the same way we use it. And what's beautiful stuff about this serializer, it's completely abstracted from types, and all you have to do is, if you have a new data type, like you want to have organization and you will create struct organization, then all you have to do is just to expose your members. And then the proper serializer will be found while you're doing serialization, deserialization. Here I also added deserialization, which is very simple. In this case, we simply, what do? We simply read the values members. So here I want to point out to the function we use. So here we take object by value reference, and we want to change it, obviously, so it's not constant. And if here we were returning just a tuple of values, we wouldn't modify anything. Obviously, we need to return a tuple of references, and this very cool function, standard function, does this for us. It's very similar to if you used function stud_tie, which binds variables. It was popular to use when you call map find and it returns two values. So in this case, the function will return references, a tuple of references, and note that these references won't be to the constant members. They will be to mutable members. And this way you can work with your members very transparently. So yeah, this is all the same. This is how you can use it. If you prefer to use iString, you can simply read from it. This dash is needed simply because we read std string and we don't escape spaces. So that's the case. Let's go further. More cool stuff. So in our case, when we define abstracted serializer, we take any type, and it's better if we constrain it, and we actually need to be make sure that we take the type which implements the function's members and names. Otherwise, we are going to get errors which are very known in the C++ world for being unreadable. So this way we declare a concept exposable, which is required to have members and names implemented. And using this syntax instead of type name, you use exposable, and that's it. You continue to work like everything was the same beside the concept. As far as I recall, in last proposals of concepts, you can even write without template exposable. You can simply write exposable const ampersand, but it's not implemented in GCC. So anyway, and if you have this link, you can open this and you will see how it works. It's here, yeah. And don't forget this this key F concept. Let's go. So as an example of format, I will use YAML. It's very simple format, which was supposed to in some way replace XML and be like human readable XML. Anyway, it's a very simple format. And if you want to have an array in YAML, you just use dash, which designates an element in this array. And if you want to have a hash map, you simply use the syntax name, column, and value. So in our case, by the way, I use libfmt here, which is very fast, and this was my first experience of using libfmt, and I love it. So here we implement our encoder, YAML encoder, and we use our concept exposable. Here I try to emphasize the important stuff because this is completely unreadable. Remove CVRef decal type members. Anyway, all we need to think about is that we format to this buffer by this format string, with this format string, and we need to remember that we should leave spaces, enough spaces, align properly our types, our values. Otherwise, it just be semantic error. And in this case, we have key value. Now, in this case, we have object which can be represented as which can be represented in key and values. And here we using the same, mostly the same fold expression, which takes, which expands into formatting spaces, name, column, and then the next call will be to call this abstracted serializer again with increased alignment. And this is done because, for instance, employee can contain a nested object. So we want to serialize it as well properly instead of just printing its value, which is probably unknown how to print by libfmt. Um, so that's basically it. And this is the way we specify our encoder for a collection, for stud vector in our case. And as I previously mentioned, every element is prepended. It is prefixed with a dash. And basically all we have to do this here, we iterate over objects using simple for. We output dash, and then we call the serializer with increased alignment. And so yeah, we will see a full example of this, but before just to show you, this is the output. We will see. Looks pretty much simple. So let's go with this link. Don't be scared. let's go here. And there is a lot of stuff here. So this is our primary template. And it's just supposed to forward our value to format 2 to libfmt, and that's it. If libfmt doesn't know how to format this value, it will give us more or less nice error message. Here further we specify our template for exposable types. As I described before, we use the dict syntax, which is a key column value. And then specialization for stud vector, which is very, very simple. And the main function, which is taken an object, creates memory buffer, and then it calls the implementation and returns to the string. And what's very cool about memory buffer in libfmt, it's in some way stack buffer. It's a buffer allocated on stack. By default, it allocates 500 bytes, and if you reach the limit, it will be copied into dynamic memory, and it will continue to grow. So yeah, and oh, by the way, it's worth of mentioning that these implementations, they don't depend on data. I just only use common functions and libfmt, and that's basically it. If we go to main.cx6, we will see how I can use it. Just if I need to serialize a number, I will do this. I will declare a number, and then I will print it. This encoder will return stud string. And this is the way we can print stud vector as YAML, and organization, which contains a nested object. Yeah, so by the way, this is a YAML representation of a organization object, and it has a nested object employees, which is in its turn stud vector of employees. So cool thing, it works and it prints, it serializes. Yeah, so yeah, and I think you demand numbers. You want to see what's cooler, what's shorter, what's not. So yeah, I did a small benchmark. Sorry for crypto names. But this Meta YAML FMT, this is implementation which uses my approach plus libfmt to format the output. Meta YAML CPP, it's implementation of my approach plus the library YAML CPP. And this YAML CPP is using library YAML CPP as it's being recommended. Yeah, and let's first see how they are. Let's see the implementations. first of all, and then we can interpret our numbers. So as you can see, the implementation, this is how YAML CVP is supposed to be used, and it depends on data. You have to tie your operators, your overloaded operators to your concrete types, which is sucks. And you use this API, which is key value, and as you can see, these field names are string literals, and it's very easy to make a typo or to forget to add something, or it's very often while you implemented serializers, you will do copy pasting, and it's very easy to forget second A in salary or something else. So yeah, and of course, this traditional YAML CVP approach can be implemented with my Meta-serializers, and we're gonna see how it looks. It's the same. It's all about the same templates and their specialization. So primary template is trust YAML CPP library, and simply gives it to YAML emitter. And if we take exposable something, then we represent it as a dictionary, and use key and value. Cool thing, you also have to start your map with this begin map and end map. And if you have something iteratable, you begin sequence, and yeah, you call the our abstracted serializer on an element of sequence. Yeah, and simple one function interface, taking an object and calling the implementation. Then it returns string. I didn't include deserialization because it's way harder, obviously. And my purpose here just to show you and educate. Yeah, and just for note, I use a Google benchmark to bench. It's a lot of repetitive stuff, which we can skip. And let's see the numbers and try to represent them. So Meta YAML FMT, I hope you still remember what it is. It wins in all cases, and it wins a lot. YAML CPP is very slow itself, but let's see if we add additional overhead with our approach. And it seems to be we don't add overhead. It's even faster slightly, as you can see, 6706 and 6592 nanoseconds. But if we simply serialize one single integer, we can see misleading micro benchmark results. I don't know why, but for some reasons it's slightly slower. The differences are tiny, so yeah. But I want to believe. But I mean, for purposes, I think they are equal. So yeah. But it's kind of you can repeat these numbers. So if we run again, By the way, here you can see Meta-YAML CPP slightly slower. Yeah, it's hard to measure and hard to say if we add overhead or do not. I believe we don't.
You can just consider them equal. There's already other processes running on it.
Yeah, a lot. A lot over H is 3, so it's you see. It's not really representative here. So, did I mention everything? Did I mention we are hiring? So this is QA section, and if you have questions, ask me. I'm glad to answer any questions.
I'm really curious how that CPU processor stuff works out for all the fields are in the structure.
For which one?
So yeah, the CPU processor micro that was working at the fields,
Mhm.
looking at the members of the structure. I have no idea how you do that in the process.
Yeah.
Idea how it works?
You skipped my previous talk. I was explaining how it works. So in this case, well, basically, no, I don't remember. I will not explain it right now. But it's tons of concatenation of macro names to determine if the argument list has been exhausted, has been finished, and you yeah. I will give you a link to my previous talk. Anyone else?
Last part you mentioned about that was this more sort of batch processing task? Yeah, that was been changing that time and all that stuff. These are more sort of the code lexical and part that has been changing. Because the last figure was I think 699 in terms of serialized single employment.
I don't quite understand. You mean these numbers which we got? They are different.
So it is more sort of in batch processing based because there is a task scheduler in whatever the system you are having and next it depends upon the optimizing capability of whatever the work you are installing.
Let me see if where is it? I think I closed something. Okay. Give me a second.
So are the numbers in the slides generated on the same machine that you're showing the terminal from?
Oh yeah. Sure. And I also want to show the code which is used. Here we simply declare the stud string in every iteration, and we give our compiler the knowledge that it might not be used, and it shouldn't be optimized out. And yeah, we simply call this stuff. Yeah, that's all. More questions?
Definition, how you got that to compile bench?
I don't really know how to measure it properly, but let's see. I don't really have to compare with something, but we can try. How's it time? Well, it takes time to, yeah. I think it adds like 1.5 seconds. Let's try to kill something. It's gonna be quick. Trying to do this one hand. So let's use the traditional stuff. I believe it's very simple. And kill everything else. We don't really use here anything non-traditional. And yeah, so, and if we add it, so remember 130, 125. I think its FMT is very slow to compile. Yeah, I blame FMT. It's very slow to compile. My code is perfect. So if somebody knows the implementator of libfmt, please let him know that he needs to work more and that we're also hiring. Let's see if I instantiate templates actually, because otherwise it doesn't make sense. Just C++ parsing. So I killed the version FMT. I believe it's going to be quite fast. So it was 130. Yeah, and still add up a half of a second. And if I include FMT, it's gonna kill us. Anyway, it's slow to compile, but very fast to run. I think it's more important. And it also has the compile time check of format strings, and it also is able to print more or less nice error messages. So I blame FMT. It's very slow to compile. Yeah.
So in the same way that this makes issue the web code.
Oh.
So this meta classes and introspection and all these things make easier to write code because it removes a lot of boilerplate.
Yeah.
Do you have any opinion on the effects of reading code?
So
do you think it's easier to read the code with these techniques or
let's see, here the macro is relatively easy. All you need to know is simply that my MacBook is dying. That you can have data structures in preprocessor which can be list, and you can transform it to run a mob function. You give it a function, a macro to transform, and this is a macro simply translates your identifier name into a string literal. And after that, this is utility macro, which converts your list into list of arguments separated by comma. But, let's see. So it's very hard to compare this approach with meta classes and reflections in turn, because this is a very simple example. But if we want to have more complicated, sophisticated logic, then then your marker will be way more complicated, and it's markers. The problem of marker, it's very hard to debug, even though we can run per processor separately, but it still doesn't give quite idea what's going on. And also you have to do tricks with recursive macros. And so when you need to do something more complicated, you should be able to use reflections or meta classes, which in its turn is simply a C++ like code which you can read, and you can give it to a developer and he will read it probably, I hope. So yeah, do I answer your question?
What's your opinion? So I guess
In my opinion, we need to use reflections and meta classes here. The only reason I use a macro here is because I need to run the to do stringinization. It's I use the hash operator for identifier to translate your field name into string literal, and that's basically the whole reason. But if you have meta classes, we can easily embed these functions members, and it's gonna look like a clean C++ code. Actually, if I can show meta classes proposal with a cool picture, which shows if I find it, if I still have time. Do I have time? No, it's not here. Mostly here. Oh, I think this one.
maybe you can stop here. Maybe you can put a comment on the meetup page. Details.
I think it's somewhere. Oh, yeah. So cool thing is, for instance, here, it's just like if you implement, how do I make it bigger? If you implement the keyword as a meta class, oh my gosh, where am I? I'm lost. Gosh, I don't see it. Oh, it's here. So if class was a keyword implemented in meta class, so everybody knows that class members are private for by default. And here the meta class implementation iterates over its members and makes them private. And as output, you have this class definition on the right side. So constructor and destructor by default, and your members are private. as expected. And if you use struct, yeah, so basically it will output all your struct members as public by default. And in our case, we can also add to the meta class implementation that we should iterate over members and create a function which will return a tuple to references to members. Yeah. More questions? I think it's done.